All right, let's jump right in. We're about to crack a code that's been hiding in plain sight your whole life. It's a fundamental secret that runs through every single whole number you've ever used. So, welcome to our explainer on the secrets of even and odd.
Seriously, just think about that for a second. What if every number, like 2 or 17 or maybe 1024, had a hidden identity that could tell you exactly how it was going to behave? Well, here's the thing. They do. There's this whole hidden world of super predictable patterns, and I promise, once you see it, you're never going to unsee it. We're talking about the simple, powerful properties of being even or odd. To really get this code, let's start by imagining that all whole numbers belong to one of two teams. You've got team even and you've got team odd. Now, the biggest difference between these two teams is incredibly simple. Picture you have a bunch of something, anything. If you can split that group into two perfectly equal smaller groups with nobody left out, then that number is on team even. But if you try to split it and there's always one left over, well, that number is on team odd. It's really that fundamental.
So let's put a slightly more formal definition on it. An even integer is just any whole number that you can divide by 2 perfectly. No leftovers, no remainder. That formula, n equals 2k, all that means is you can get any even number just by taking some other whole number, k, and multiplying it by 2. That's it.
And this works for all sorts of numbers. You know, the obvious ones like 2 and 8, bigger ones like 124, and yep, even negative numbers like -10. And what about 0? Since you can divide 0 by 2 and get 0 with no remainder, it is definitely on team even.
So, what's the deal with team odd? Well, an odd integer is the exact opposite. When you divide it by 2, you always have a remainder of 1. That little plus 1 you see in its formula, n equals 2k plus 1, well, that's it. That's the one little piece that's always left over.
And again, this applies to every odd number out there, from the simple ones like 1 and 3 to negative numbers like -5, all the way up to something like 357. They all share that exact same quality, a remainder of 1 when you divide them by 2. Okay, that's great for numbers you can easily picture. But what about a massive, complicated number? Well, this brings us to a fantastic trick, a super simple shortcut that lets you identify any number instantly.
So let's take our example from before, 357. I mean, you could sit there and try to divide it by 2, or you could use a much faster method. Here's how you do it. It's the 3-second check. All you have to do is look at the number, 357 in this case, and completely ignore everything except for the very last digit. So we're just looking at the 7. Now, just ask yourself, is the number 7 even or odd? That's because the last digit tells the entire story. Since 7 is odd, the whole number, 357, is odd. It's that easy. If the last digit is a 0, 2, 4, 6, or 8, the entire number is even. The secret is always in that final digit. So now that we can spot them in the wild, what happens when these two teams actually interact? You know, what happens when we add them, or subtract them, or multiply them? Well, it turns out the results are amazingly predictable. The pattern for adding and subtracting is just fascinating. If you combine two numbers from the same team, so an even plus an even or an odd plus an odd, the result is always even. But if you mix the teams, an even plus an odd, you're always going to get an odd number. It works every single time. Now, for multiplication, there's one golden rule that basically trumps everything else. It really shows you the power of team even. If an even number shows up to a multiplication party, it controls the outcome. Period. The results here are crystal clear. Even times even is even. Even times odd is also even. See? The only way you can possibly get an odd result is if you multiply an odd number by another odd number. That one even number is all it takes to make the entire answer even. So, let's lock in these master keys. These are the unbreakable rules, the absolute foundation of this entire number code we've been cracking. But first, one final pop quiz on a number that sometimes trips people up, 0. Based on everything we've just talked about, what team is it on? 0 is definitely 100% an even number. It fits the definition perfectly. 0 divided by 2 is 0 with no remainder. It's kind of like the official starting point for team even. So here it is, the whole code in a nutshell. Every integer has one identity. It can't be both. They switch back and forth perfectly down the number line. That last digit is your ultimate shortcut. Adding 2 from the same team always gets you an even number. And remember, in multiplication, team even always wins. These are the core patterns that just run through our entire number system.
And all of this leaves us with one final thought. We just uncovered this simple, really elegant code that was just hiding in plain sight. It kind of makes you wonder, if something this fundamental has such a clear set of rules, what other amazing secret patterns are just out there waiting to be discovered in the world of math?